So this is Monday, the 6th of March, and here we are evaluating derivatives. Okay, so question 1, y equals 2x cubed minus 4x squared plus 1 at x equal to 2. Okay, so the first thing we want to do here is to find the derivative. Okay, so we're going to rewrite the question. Y equals, so 2x cubed is fine, that's fine, minus the 4x squared is fine, but the 1 I'm going to change. Okay, so am I going to use x to the power of 0 is 1 or x to the power of 1 is x? So it's going to be one of these here that I'm going to substitute. So if I put in x to the power of 0, that'll still be 1, so 1 times 1. So I'm going to use 1x to the power of 0. And now I've everything in terms of a power. So I can find dy dx is your derivative, which is equal to. So I'm going to multiply by the power is 3 times 2x. Reduce the power by 1 becomes 3 minus 1. Minus multiply by the power is 2 times 4x. Reduce the power by 1 plus multiply by the power is 0, 1x, and reduce the power by 1. So 0 take away 1. So 3 times 2x gives us 6x. 3 take 1 is to the power of 2, minus 8x. 2 take 1 is to the power of 1, plus 0. And we know that x to the power of 1 is the same as x, so my answer will be 6x squared minus 8x. So I can ignore the 0. Okay, and that's our derivative. And now we're going to substitute at x equal to 2. So in this case we have 6 times 2 to be squared minus 8 times 2. Which gives us equal to 6 times 2 squared is 4 minus 16. So 24 minus 16 is equal to 8. So our derivative at that function, when x is 2, our answer is 8. Okay? So question 3 on the sheet. We have y equals 4x cubed minus 3x squared plus 2x minus 1 at x equal to minus 1. So again, what I'm going to do is I'm going to rewrite, because I want a power everywhere. So that's fine, that's fine. This one I can change to x to the power of 1, but the minus 1 is the problem. So I'm going to have y equals 4x to the power of 3 minus 3x to the power of 2 plus 2x to the power of 1. Now, I want, say, minus 1 times 1. And I know that x to the power of 0 is 1. So therefore, take away minus 1 x to the power of 0. And now we know the first thing we're going to do is apply the rule for the derivative. So we're going to multiply by power in the first step, and then we're going to reduce the power by 1. Okay, now that's our rule. So in this case here, dy dx is equal to 3 times 4x. Reduce the power by 1, so 3 minus 1. Multiply by the power, 2 times 3x. Reduce the power by 1, 2 take 1. 1 times 2x. Reduce the power by 1, so 1 minus 1. Minus 0 times 1x to the power of 0 minus 1. Okay. Which gives me equal to 3 times 4x is 12x. 3 take 1 is the power of 2. Minus 6x to the power of 1. Plus 2x. 1 take 1 is 0. Minus, and all of that is just going to give you 0. So we know again, x to the power of 1 is x, and x to the power of 0 is 1. So our answer will be 12x squared minus 6x plus 2. Okay? Now we're going to substitute at x equal to minus 1. 12 times minus 1 squared minus 6 times minus 1 plus 2. So 12 times minus 1 squared is plus 1. 2 minuses give me plus 6 plus 2, which is equal to 20. Okay? Next one I'm going to do for you. So y equals 2x squared minus 3x plus 1 times x squared plus 5 in brackets, and that's at x equal to 0. Okay. So in this one here, the first thing we're going to do is our brackets. We're going to multiply. Okay? So everything in the first bracket times everything in the second bracket. So we have y equals 2x squared times x squared plus 5 minus 3x times x squared plus 5 plus 1 times x squared plus 5. Multiply out, y equals, that's 2x, and x squared by x squared is x to the power of 4, plus 10x squared minus 3x cubed minus 15x plus 1x squared, and 1 times 5 plus 5. So I'm going to tidy that up. Y equal to 2x to the power of 4 minus 3x cubed plus 11x squared minus 15x plus 5. Okay, because I have x squareds and x squareds, so I've tidied them up into 11x squared. Now I'm going to get my derivative, dy dx. Okay, I'm also going to put x to the power of 1, and 5 on its own will just dy derivative of any constant equal to 0. So you don't even have to put in your 5x to the power of 0. Okay, we know that 5 is going to go to 0. So in this case, dy dx is equal to 4 times 2x, reduce the power by 1 becomes 3, minus 3 times 3x, reduce the power by 1 becomes 2, plus 2 times 11x, reduce the power by 1 becomes 1, minus 1 times 15x, 1 take 1 is 0. Which gives us 8x cubed minus 9x squared plus 22x minus 15x to the power of 0, which is equal to 8x cubed minus 9x squared plus 22x minus 15, because x to the power of 0 is 1. And now, to substitute x equal to 0, we get 8 times 0 cubed, 9 times 0 squared, 22 times 0, minus 15, and our answer is minus 15. Okay? Okay, and the last one of these, y equals x cubed minus x squared plus 1x minus 7 at x equal to 0 again. Okay, so here we know that minus 7 is going to be, so if y equal to minus 7, we know that the derivative is equal to 0. So that's going to be gone. And we also know 1x to the power of 1. So our derivative, dy dx, is equal to 3 times 1x, reduce the power by 1 becomes 2, minus 2 times 1x, to the power of 2 take 1 is 1, plus 1 times 1x, to the power of 0. So we get 3x squared minus 2x to the power of 1 plus 1x to the power of 0, which is 3x squared minus 2x plus 1. At x equal to 0 gives us 3 times 0 squared minus 2 times 0 plus 1, which is equal to 1. And that's evaluating our derivative. Okay, always number 1, simplify, which may involve rewrite or multiply brackets. Number 2, dy dx, or your derivative. And number 3, to substitute. And that's all part of evaluating our derivatives.